Hello folks. So today we will build another kind of particle life, and this is called Conway's game of life. So John Conway, he is a mathematician, and he created this cellular automata, and this is also called game of life. It has some very simple rules. So for example, all the white boxes and black boxes that you can see here, the white boxes are living cells and the black boxes are dead. So if a living cell is surrounded by two or three cells, then that living cell will continue to live. And if it is surrounded by less than two cells, then it will die by underpopulation. If it has more than three cells, also, it will die by overpopulation. And all the dead cells, they are dead cells unless they are surrounded by exactly three white cells. So if a dead cell is surrounded by three living cells, that dead cell will be alive in the next turn. So for example, you can see this box here, right? This box is surrounded by three white cells. So this box will become alive next turn. But all these boxes will become dead the next turn because these boxes are not surrounded by two or three white cells. So I can click on the next turn and see, as we can see, we have an alive cell here and all the surrounding cells are dead. Now in the next turn, this cell will also become dead because it is surrounded not by any white cells. So next turn, this will also become dead. And like this again, we'll move on. But what we can do is we can keep on doing next turn, and we will see how it behaves. And we can also do a start, and it will do it on its own. And this is how the game of life will progress. It is also called a zero-player game. It the rules are defined, and we'll see what comes out of it. And we can see something very interesting. There is a line that is becoming horizontal and vertical. So these are also called oscillators. Here there is another one, and that is now gone because something else came close to it. And there are also a lot of stable, like some stable particles. So for example, these boxes. So all of these boxes are alive, but there are no surrounding cells that can be born out of it. So all of these are stable structures, and there are some oscillators, and there are some particles still moving here and there. So it's a very interesting project, and let's see what we can make out of it. And yeah, so we also have another particle that is moving in a constant pattern, and I believe it will come in contact with the box very soon, or maybe not. Let's see something comes out of it or not. Yes. So it changed the box, and yeah, it's gone. It came here and it's gone. And this is a stable structure that we got at the end. We have two oscillators and a lot of very interesting stable particles. So let's see how we can code this thing out, and let's go to our VS Code. So in my VS Code, I have a very self-explanatory index.html file over here. We have a canvas, we have the two buttons, next turn and start, and we also have a script.js file connected, which is empty for now. And here we will start by defining our canvas equals to document.querySelector canvas. And then we have to define the CTX. So canvas.get context 2D. This is all very simple stuff. Then we'll define the width of the canvas to be 500 and the height of the canvas to be 500. If we go to our browser, this is how it looks like for now. One empty canvas and two buttons. Let me also open the console. Right now there is nothing, but very soon there will be some things. Next, to draw our grids, we need to define some dimensions. So we'll define the grid side to be 25. This will create a 20x20 grid. And then we also need to get like how many grid rows and columns are there. So grid rows is basically our canvas.height divided by grid size. And same goes for grid columns. So grid cols equals to canvas.width divided by grid side. And then we also need to define a grid. This is an empty grid for now. And we will also create another next grid. This is required when we are updating the grids. And now we can start drawing our grid. So we need to first initialize our grid. So initialize grid. This will be a function, and then we need to draw the grid. This will be another function. So function initialize grid. We will write this soon. And then function draw grid. So what does initialize grid mean? So we have a 20x20 grid. We need to define that what those like boxes are or cells are. So what are the color of the cells, black or white? So what I will do is whenever a grid has the value 1, it is a white cell, and whenever it has a value of 0, it is a black cell. We are not using grays here. In the future, we may do. So for now, it is only 1 or 0. So defining that is actually very simple. We have to randomize and initialize, that's all. So we'll create two for loops inside the initialize. So I equals to 0. I should be less than grid false, I plus plus, and then for let j equals to 0. J should be less than grid rows, and then j plus plus. Then what we will do is something like this. We have to, for the value of grid ij, this should be either 1 or 0. So what we will do is we will create a random number. So let rand equals to match.random. This is a this is a random number between 0 and 1. So if let's say if rand is greater than 0.5, we will make it 1, that is white, otherwise 0. Now we can also make it 0.7. In that case, the number of whites will be a little bit less. That's all. So now let's go back to, and we have some errors. So cannot set properties of undefined setting 0 in line number 21. So here there is some issues in setting up. And the reason is our grid is actually a one-dimensional array. And here we are trying to access a two-dimensional index. So to do this, what we need to do is simply for the value of grid I, we need to say that this is also a one-dimensional array. And now our error will be gone, but we still don't have anything because we are not drawing it. If we log the grid, we will see that we have lots of values. So here, so this is a representation of our grid, but we also need to draw it here. So let's do that now. So in our draw grid function, again, we need to take these two loops. We don't need the grid I for now. And now what we will do is, we will simply start drawing. So ctx.begin path, then line width, let's make it 1. ctx.stroke style, let's make it white because we are drawing in black. And then ctx.stroke rect. So what is the x? The x is j multiplied by the grid side. And the y is I multiplied by the grid side again. And the w and h, width and height, are both grid sides. So grid side, grid side. Then we need to do ctx.stroke. Now let's see if we get something or not. And we have a grid, but we don't have the white and black squares as of now. I mean, all squares are black right now. So what we need to do is we need to check if the grid ij, if this is equals to 1, we'll give the fill style as white, and we'll do the ctx dot fill rect. Let me just copy this line, and instead of stroke rect, this will be fill rect. And otherwise, we'll do the opposite. So ctx dot fill style equals to black. Now you might wonder that we already have the whites, so the remaining other blacks. So what's the big deal? But we also need to draw the blacks, I mean fill the blacks, because when we are doing an extern and start and it is like changing the colors, so if we are only drawing whites, then sometimes we also need to draw blacks on whites, right? So because of this, we also need to define this. So very simple and straightforward reason, and that's all. And in the end, we will do a ctx dot close path, and we are done. And this is how it looks like now. So if we refresh, we will have lots of interesting shapes. But this doesn't work right now. So let's see how we can make it work. So to make it work, first of all, we'll click on the next turn. And by clicking on the next turn, it should update the grid. Let's see how that can be done. So what we will do is whenever we have in next turn. Okay, we need to define that actually. So before the grid, we have two buttons, right? One button is next turn. So this is document.get element by ID next turn, and we also have a start. This is again document.get element by ID, and this is a start. So whenever we are doing a next turn dot add event listener and we are clicking on it, we need to do something. And what we need to do is we need to update our grid. We need to do something like this. Now, what is an update grid? An update grid is basically changing the numbers of this grid, right? So we are defining some numbers here and we will change these numbers. So we need to write a function called update grid, and this will be quite a tricky function. So function update grid. Here, what we need to do is, first of all, we need to define our next grid. So we have created a temporary next grid. So we'll define that. So next grid is what? It is basically whatever is our grid right now. So grid map, we will get a row and we'll return the row by destructuring. So we got the next grid and then we need to do the same things again. I from 0 to I less than grid calls, I plus plus, then j equals to 0 to j should be less than grid rows and j plus plus. Now we need to calculate few things. So for living cells, we know that uh, it should be either two or three. So if a cell, a living cell, has two or three neighboring living cells, it will continue to live on. Otherwise, it will die. And for reproduction, a dead cell should have exactly three living cells in the neighborhood. So here, what we need to do is we need to find out how many neighbors are there. So let me say it like this. So let neighbors equals to neighbor count of ij. And this is a function that we need to write right now. And when we got our neighbors, what we will do is, so if grid, let's say iej, if this guy equals to 1, which means if this is a living cell, and then we need to check the neighbors. If neighbors is less than 2 or neighbors is, let's say, greater than 3. If this is the case, then in the next grid ij, we will make it 0 because in this case it will die. So living cells die. This is what we are checking here. And for the reproduction, we will check first of all if the grid ij is dead, because only then the reproduction is possible. So if this is 0, in this case, if neighbors equals to 3 exactly, in that case, next grid ij will become 1. And lastly, we will do grid equals to next grid and the same things dot map. We will have a row and we will return destructured rows. 3 dots. Yes. Now there will be an error. No errors because we are not calling it. So if we click on the next turn, there will be errors, and that is neighbor count is not defined. Because it's simple. We have created something called neighbor count, but we have not written the function. So function neighbor count. This is something that we will write right now, and this will contain an I and a j, which is basically the index. So ij, and here we need to check 8 cells. So if we are in this cell, we will check 8 cells. And 8 means this all these neighboring cells. So which cell is what? We need to check right now. So in the neighbor count, first of all, let's say count equals to 0. And now what we will do is this. For the 8 cells, either it is 0 or 1. So for 1, we will increase the count by 1. For 0, we can increase it by 0. It doesn't matter. So we will simply do it like this. So grid I minus 1 and j and j minus 1. This is the top left. Hmm. And then only the top one. So this will be grid. Well, this is actually, if we consider the I to be columns, so this is I minus 1, j minus 1. So this is the top left. So if this is the cell we are taking, so this corner, then this will be I minus 1, j. This will be this will be I minus 1, j plus 1. So like that, there will be 8 cells. And if we consider the I to be rows, so this will be I minus 1, j minus 1. This will be I, j minus 1, and this will be I plus 1, j minus 1. So whichever way you take, this is how we will calculate. So this is the first case. The second case is I minus 1, j. And the third case is what? Plus equals to, this will be grid I minus 1 and then j plus 1. Now here, there is little bit of an issue. And the issue is, if we are at the corner, so here both I and j are 0. So I minus 1 will be minus 1 and j minus 1 will be again minus 1. Or in this case, I minus 1 will be 0, but j minus 1 will be minus 1. So we have some conditions that we need to take care of. So if I do a next turn, so as we can see, cannot read properties of the, undefined reading minus 1. And because the minus 1s are coming, so we need to take care of that. So how we will take care of that is we will simply exclude those cells from being checked. So this is the top row. And here what we will do is if I is not equals to 0 and j is not equals to 0, only then you check the first line. And then for the second line, only when I is not equals to 0, you check the second line. And for the third one, it is little bit tricky. So when I is not equals to 0 and when j is not equals to grid rows minus 1, only then you check this. Now why so? Because j plus 1, this will cause issues whenever we are at the end. Or like if this is a row, so we are at the end. So this is the index 19 and j plus 1 is 20. So outside the grid. So there is no index 20, so this will cause issues. So if this is grid rows minus 1, that is 19, then you don't check this one. So now if we do this next turn, mm, okay, cannot read properties of undefined reading 1. Okay, so this is not yet complete. So let's complete this, but the idea is this is how we will take care of this. Okay, so our top row is done. Then we'll take care of the mid row, and then we will take care of the bottom row, and lastly we will return the count. That is very important. Otherwise, they are not even getting anything. So for the mid row, what we will do is count plus equals to our grid I j minus 1 and count plus equals to grid I of j plus 1. No ij because ij is our own cell that we don't need to check. So here, first of all, we will check if j is not equals to 0. Only then you do this. And for the second one, if j is not equals to grid rows minus 1, in that case, you check the second one. Yes, and for the last one, what we need to do is we need to check the bottom row. So in this case, our count plus equals to, it will be grid I plus 1 and then j minus 1 and second one will be j, third one will be j plus 1. And here, instead of checking I not equals to 0, we will check I not equals to grid columns minus 1. So if I is not equals to grid calls minus 1, so let me copy this one because we need this many times, and j not equals to 0. This is the first case. The second case is only this. And the third case is this. And j is not equals to grid rows minus 1. And this is the third case. Now let's see. We have something better or not. So we still have some issues, and that is cannot read properties of undefined reading 1. And this is script JS line number 89 and update grid line number 61. Okay, 89 and 61. Let's see what issues do we have. 89. 89 is this line. So count plus equals to grid I minus 1. Okay, so this is 1 instead of I have written 1. So very silly issue. So now I believe there will be no issues. So we are clicking on next turn and there are no issues, but there we don't see any changes. And that is because although we are updating the grids, we are not drawing again. So after the update, we also need to draw. So let me do that. So here we are clicking on the next turn, we are updating the grid, and then let's also draw the grid. Now, whenever we are clicking on the next turn, we see that our automata is actually changing. So let's see if the rules are applying or not. So this one should be alive next turn. Let's see. And yes, this is alive. So the next turn, another one that will be alive is, I believe, this one. So yes. So I believe this is working. This will be alive next turn. And yes, so this is working. So we got one automata, but we don't want to keep on doing next turns like this. So instead of that, we will click on the start, and it should take care of on its own. That is what we want. Now that is actually very simple, and in the end, what we will do is start.add event listener and click. And if we click, what we will do is we will do a set interval, and here we will do the update grid, and then we will do the draw grid, and then let me give an interval of, let's say, half a second or 1/4 a second. Now let me click on start, and we have our beautiful cellular automata, and it will play on its own because it's a zero player game anyway. And this is what it is. Now we can also increase the count. So I think it has no, it is still something is left. So instead of 20 cross 20, let's make it 50 cross 50. So I believe that will be more fun. So here at the top, instead of 25, we'll make it 10. All other things are variables, so it will work perfectly fine and start. Yes. So this is something that I was showing you in the beginning, and we have also made this one. So now you can give me more ideas of how to make this game more interesting. So there is one interesting idea of making gray shades. So for example, we don't kill cells right away. Instead of that, we make cells as gray. So in place of 1 and 0, there are a lot of in between values, and there are a lot of interesting behaviors like that also. But yeah, this is the very simplistic model, and as we go forward and we get new ideas, we can definitely make a lot more new things. So folks, that's it for this video, and I will see you soon with another very interesting video on some new topic. Let's see what it is.